Okay, okay, let's start with the practical session. So I'll do two sessions, one with the basic practicals, and the other one I will do bit of advanced settings and how to set up routers and all that we'll do later. So we'll do this in two sessions, and after this OSI model and the practical part would be completed, and then we can move on with the IP section. Okay, so first of all, I think you guys should have a basic understanding on what IP addresses are and how IP addresses work. And by this point, you should know why IP addresses are used and how we can use them, right? You guys know that IP addresses we can use mainly for two things. We can use IP addresses to identify networks, right? Identify networks in a larger network, right? We can prefer, there are, if you take internet as an example, the internet is made out of different networks. There are millions of networks inside the internet, so it's a interconnection of networks. So ip addresses helps you to find out which network you want to address out of these whole bunch of networks. So it identifies networks. That's one thing. And the second one is IP addresses create networks, right? Because in the internet there are no physical barriers, right? In the same room there can be many networks. In the same room, in the same small room, there can be many Wi-Fi networks. So so we can't identify these networks based on physical barriers. So there needs to be some sort of a virtual barrier to identify these networks, right? To identify these networks separately. So that's where IP comes in. IP helps you to categorize computers into a virtual network, right? So there are two uses of IP addresses. It identifies networks and also it creates networks. So in this part we'll cover both the areas. So first of all, let's start with the most basic option. Let's take two PCs, right? If I want to configure these two as a network, what I can do is I will need to get a crossover cable, not a through cable, crossover cable. I will connect the fast Ethernet port of this machine into this machine, right? So I'll name this A and B. I will name this A and B, and this would be B, right? So now the physical layer is set up because I got two computers and I connected both computers with single cable, an Ethernet cable or a RJ45 twisted pair cable. So now I am done with my physical configuration. Now what I can do is I can move on with my virtual configuration. So there are few layers to the network. The first one is the physical layer. Now the physical layer configuration is set up, and the second one is the data link layer, right? In the data link layer we need to configure MAC addresses and the Ethernet protocol we need to configure. Okay, if I open this computer, the PC1, you can go to the go to desktop. You can go to desktop, and if I open the terminal, if I open the terminal, so if I open the command prompt, I can use this machine as a virtual machine. I can do all sorts of testing in this machine, right? Give me a second. So if I try to find out my IP address, these things are not currently set up, so they will give me empty values. If I try to get out the MAC address, if I try to find out the MAC address, you can try this. You can find out the MAC address this way. So this is the, you can see this is the MAC address, the physical address. currently this computer actually has a physical address 00D0. This is the physical address. This is the short form of the physical address. So now we can see that the Ethernet or the data link layer is already set up, right? We don't have to set up MAC addresses to these computers. So if I open the second computer, go to the desktop command prompt, if I type ipconfig all, here under physical address, you can see that there is a MAC address that has already been assigned. So this MAC address has already been assigned by the computer manufacturer. You don't have to set this up. You don't have to set this up. So the data link layer is usually it's it is configured automatically. You don't have to worry about the data link layer. So the MAC addresses and the Ethernet protocol, they have been already set up in your computer when you at the time you bought them, right? Even at the time you bought them, these things will be automatically set up, right? So you don't have to worry about the data link layer. And the third layer is the network layer that you need to worry about. You need to create a network using IP addresses, right? That is the only way that A and B, these two computers, can talk to each other. Currently, if I try to ping these two computers, if I try to ping from computer A to computer B, it would not work. That thing would not work, right? I would not be able to ping from computer A to computer B. If I try to open ping this computer, if I try to ping the computer B, I would not be able to ping computer B because I don't even know the IP address, because those things are not already set up. So what I will do is I will provide my IP addresses to these computers. For this I will set 192.168.120.1. To this one I will set 192.168.120.2/24. /24 is the MAC is the default subnet mask. Sorry, the subnet mask. You don't have to worry about the subnet mask. Okay. So these are the IP address that I'm going to assign to computer A and computer B. So to computer A, I will come to this IP configuration. So under IP address 4, I will set 192.168.120.1. Subnet mark is automatically assigned. Automatically now. Default gateway, I will keep it like this. For now, DNS I will keep it like this, and I will close this thing. And I will open the configuration window of computer B as well. I will come to IP configuration. I will set 192.168.120.2 and the MAC address and the subnet mask. It automatically pops up, right? This field is automatically filled when you enter the IP address 4 here in the above field. That is automatically filled up. So you don't have to worry about these subnet masks at this point. At this point of the training, you don't have to worry about this, right? You only have to worry about the IP address. You can see that these two IP addresses belong to the same range, right? You can visually see that these two IP addresses belong to the same IP range. So now these two computers, computer A and computer B, are in the same network. Now we have fully set up the IP addresses in computer A and the computer B. So now the network is already set up. Now what I can do is I will open computer A. I will open the command prompt. I will try to ping computer B. I will type ping 192.168.120.2, right? So this is the IP address of computer B, right? I will try to ping this IP address. You can see now you're actually getting the reply, right? Reply coming from 192.168.2. You have sent 4 packets and you have gotten 4 feedbacks from those packets. So the success rate is 100%. You can see 4 sent, 4 received. All 4 packets have received their feedbacks. So which means the loss is 0%, right? The accuracy rate of the total success rate is 100%. We have gotten feedback to each and every packets that you have sent to computer B, which means the network works. If I try to open computer B's configuration panel, open command prompt, if I try to ping 192.168.120.1, which is the IP address of computer A, you can see that I can get the reply. Right? Reply coming from this thing. Loss is 0, right? Loss is 0. You can get the reply. Loss is 0, right? 4 packets sent. received for. You have gotten the feedback for all 4 packets, which means it works. The network works. So this is the most basic network you can create with first 3 layers. So which means you can't really create any network without the help of first 3 layers. You need to use the first 3 layers. Without that, you can't really do anything, right? You don't have the capacity to do anything if you don't use the first 3 layers, right? For you to create a simple message through the network, you need to use the first 3 layers. That's the basic principle of networks. So if I try to simulate this thing, I can simulate this thing, and I can edit the filters. I will edit filters. I will add IP address for ICMP, and that's it. Okay. Now I can capture ICMP packets from the simulation panel. So what I will do now is I will send a packet, an empty packet from computer A to computer B, right? So now I'm trying to send a packet from computer A to computer B, and I'm trying to simulate the message, and I'm trying to capture the packet while it is sending to computer B, right? During this sending period, I'm trying to capture this packet, I'm trying to open this packet and see inside, right? That we can do from the simulator. So if I put this button, you can see that the packet is coming from computer A to computer B. It has already reached computer B, right? And now it has gone to the computer B. So that's what happens, right? When you ping from computer A to computer B, computer A sends a packet to computer B, and then computer B sends a feedback message to computer A, right? Once the computer A gets the feedback, the ping is set to succeed, right? Ping is set to success mode, right? Ping is set to be succeeded. Okay. Now I will destroy this message, and I will send another packet. I will send another packet from computer A to computer B. This time I will open this packet. If I click on this, I can open this packet. Here you can see the out layers. Out layers are the layers that is used in this packet, right? You can see the layer 1. I'm using the physical port fast Ethernet 0. So here what I'm using to send this packet is fast Ethernet port 0. This is connected to this computer. The fast Ethernet port 0 is connected to computer A. So that is the physical layer, right? Physical layer is already set up. And the Ethernet layer, Ethernet 2, it uses the Ethernet version 2. The header contains, this is the source MAC address, and this is the destination MAC address. So this message is coming from 00EB this thing into 0000 MAC address. And in the above, layer 3, that is the IP layer, that is the network layer. Here you can see the IP address, source IP address is 121. The destination IP address is 122, right? I'm sending an ICMP packet. You can see that ICMP message also belongs in the layer 3. ICMP packet also belongs in the layer 3. Okay. So this is the structure of the packet. This might be a little bit of complicated because you might not have seen something like this before. I have not gotten into this much of depth when I'm talking about packet structures, but this is really simple. This preamble, I will explain these things later. This preamble is basically how you try to divide, or how you try to separate a packet from another packet, right? Under synchronous communication we talked about, so asynchronous communication we talked about, when you're sending packets in a stream, we try to put time gaps as well as control bits in the middle to help the receiver to identify these packets separately. So this preamble is something like this. Preamble is sort of like a packet sequence or bit sequence where you put 101010 I think 56 times, right? There are 56 times of this 10 goes on as a sequence. This we use to divide packets. This we use to help separate the packet from another packet. And then we have the destination IP, the destination address. This is the this is the Ethernet part. This is the Ethernet part. Destination address is the destination MAC address. This is the source MAC address. This is the message type, and the variable length is there, and then some other flags are also there. Under IP addresses, we can see there are few things. not just source IP address and destination IP address, right? In the IP header, we only mentioned that IP header contains source IP address and the destination IP address, but it's not actually the truth, because there are some other things that is included in the IP header, like the version, the time to live, flags, TTL, time to live, and then some IDs are there, and then some other data is also there, right? So this is the IP header. So inside the IP header, you have this ICMP message, which is also belongs to the network layer. So this is just, you know, simple message. There's nothing inside this thing. There's a sequence number, and that's it, right? And there's a code, and there's nothing inside the ICMP packet. It's just dumb data that we use to test the database, right? And then we have the data inside the PDU unit, right? This is the data that we send. This is the test data that we are sending from through ICMP protocol, right? Okay. Now you can see it has come here. Now what this thing does is, this is the packet that is received by computer B. This is the packet that is received by computer B, right? This packet is received by computer B. Outbound packet, this is received by computer A. This packet is received by computer A. Sorry, this is the packet received by computer B, right? So you can see that the destination IP address, or the MAC address, is set to the MAC address of computer B. This is the MAC address of computer B. This is the MAC address of computer A, because this message came from computer A. In the IP section also, source IP address is the IP address of the computer A. Destination IP address is the IP address of computer B, right? In the outbound PDU is the feedback message sent by B to A. This is the feedback message. If I open the feedback message, you can see it also has the same structure. There's nothing different from what B got. B sends a similar format, but he changes some things. Here now you can see the destination MAC address here is actually the MAC address of computer A. This is the MAC address of computer A, because this thing is now sent back to computer A, right? The source is now set to MAC address of computer B, because this message is now sent by computer B to computer A. This is the feedback message. Here the type is also different, because this thing is a feedback message. This is an acknowledgement message. In the IP section also, you can see the source IP address is set to IP address of computer B. You can see this is 122, and also destination is set to computer A, because now we are sending this message from, this is the feedback message sent from computer B to computer A. ICMP is basically the same, right? There's nothing different from down here in the ICMP or the data unit, right? But here we switch out the MAC addresses, right? We set the source MAC address to be the MAC address of computer B, and the destination MAC address to be the MAC address of computer A. We did the same thing to IP addresses as well, and then only after that we can resend the packet, and that packet will go from computer B to computer A. Now you can see. Okay, now the computer A, we can click on here, and we can see what computer A got. This is the same message sent by computer B. This is the same message, nothing is different. This is what computer A got, because this is the message sent by computer B. Okay, that's basically the idea of ping, right? You set a packet, and then you wait until you get the reply, right? When you're sending the packet, you set the source IP and the source MAC to be your IP and your MAC, and the destination MAC and the destination IP to be the IP of the destination machine. And when you're sending the feedback, you are taking the same packet, but you are switching those two things. You are changing the source to destination of the in the MAC address section as well as in the IP address section, and then you are sending the feedback. So when the B sends the feedback from computer B to computer A, source MAC address is set to MAC address of B. Source IP is set to MAC address of computer B. The destination becomes the computer A, because it's the feedback message. Feedback message sent from computer B to computer A. So those things should change accordingly when you are sending the feedback. So that is basically the idea of a basic network building. Now you can test this. You can download this software. If you go to Cisco website, you can download this software for free. You might have to create an account. It's a free account. You don't have to pay anything. You can create a free account in their system, and then you can download this software and you can play around with it. Yeah? You can create really complicated networks using this system. This is just a simple setting, right? In the coming sessions, we'll discuss about more theoretical as well as more practical and more advanced stuff we'll talk about later. This is just a, you know, the surface of network creation. So we'll get into servers and all that, email servers, web servers, and we'll get to all that later. But this thing, I will just leave this as a video so that you can refer to this later, and you can download Cisco Packet Tracer and you can try this yourself. So tomorrow I will upload the second video of this series, right? And then this series might go for maybe 2 or 3 videos, and after that first 3 sessions, we'll be done with the network layers, right? And then we can move on with IP and servers, right? So I will not cover all the videos, all the sections in one single video, because the video will get seriously really long and really lengthy and really large in size as well. So I'll stop at this point, and tomorrow I will upload another video, and this video will contain uh, contain how you can create a simple network using a switch, and how you can embed routers into that network. And then in the last video we'll explain about bit of servers and how we can use the about 3 layers, which is the application, session, and presentation. How you can use those 3 layers, we'll talk about that in the session after the next.